Okay, today we are looking at double angle formulas. Double angle formulas. So like it says, it's most often used with non-unit circle values. So you're going to have to draw a right triangle rather than using your unit circle. Okay, so here are your formulas. There is one formula for sine. There are three formulas for cosine. You can use whatever one you want. I most often use this one. I don't know, it just seems easier to me to do cosine squared minus sine squared, but you are welcome to do the other two as well. And then tangent has one equation, and it is a fraction. So we'll be doing all of our fantastic fractional things, like multiplying by the reciprocal and things of that nature. So here it says to do all of them. So these ones there are formulas for, right? Sine, cosine, and tangent. There are formulas for those. And these other three are just their reciprocals, right? Cosecant is 1 over the sine. Secant is 1 over the cosine. Cotan is 1 over the tan. So once we find the sine, cosine, and tangent ratios, we're just going to reciprocate them to get these ones. So there's no formula for this. Just know that the cosecant and the secant and the cotangent are the reciprocals of the sine, the cosine, and the tan. All right, so to start off here, notice that this is our angle. This is your reference angle that we're talking about. This is your hypotenuse. 9 is your opposite side. And it looks like we are missing the adjacent side. Okay, this is a pretty classic pre-calculus test or problem, because they want you to draw back to your geometry days and use the Pythagorean theorem in order to find that missing side. So 15 squared equals 9 squared plus x squared. Okay, and the reason why I'm calling it x is because, not because x is the variable that we use all the time, no, because this is the horizontal side of my triangle. Okay, the horizontal side is your x side. If we were missing the vertical side, I would call that y. And of course, hypotenuse is hypotenuse. So just for fun, 15 squared, I think we know that's 225. 9 squared is 81. Okay, we'll subtract, of course, to use the Pythagorean theorem and get 144. So our missing side is going to have a length of 12. Excellent. Now let's get to using our formulas. So the sine, we'll do the sine of 2 theta, right? Sine, the double angle. Double angle 2 times theta, that's how we know it's a double angle, because there's a 2 in there, is called 2 times the sine of the angle times the cosine of the angle, right? That's the formula for sine of a double angle. So we're going to go to our triangle and get the ratios for sine and cosine. Remember, sine and cosine are ratios. They're comparison of two sides of your triangles. The sine is a ratio of the y side to the r radius or the hypotenuse. So y over r, in other words, 9 over 15. And the cosine is a ratio of your x side to your radius, or adjacent side over your hypotenuse. So the cosine is 12 over 15. So now it's just a matter of multiplying all these things out. So if you need a calculator, by all means get a calculator. Remember how we do fractional multiplication? That is top times top times top, so 2 times 9 times 12, over bottom times bottom. 216 over 225, well, that's your answer. Okay, this is a ratio, 216 over 225, and that is the exact value. And I do not believe that this can be reduced at all. Maybe it can. Let me see. Hang on. Pause. And the answer is yes. They're both divisible by 9. So we divide them both by 9. We get 24 over 25. Okay, pretty nice. Sine of the double angle. Okay, now let's move over and do the cosine of the double angle. So I'm going to use the formula cosine squared minus sine squared. Okay, it's just my favorite, so that's why I'm using it. And there's no ones. I don't have to subtract ones and change my fraction. So cosine, once again, was 12 over 15. Right? It's the cosine that we're squaring. So first we write down the ratio, and then we square that number. So 12/15 is the cosine. 9/15 is the sine. So 12/15 squared minus 9/15 squared. Okay, so this is 144 over 225 minus 81 over 225. So 144 minus 81 is 63 over 225, which means I know both of these are now once again divisible by 9. Divide them both by 9, and I get 7 over 25 as my final reduced answer. 7 over 25. All right, so those are the easy ones. Now let's look at doing our tangent. Okay, and the only reason why I say tan is less easy is because it has this fraction in it. Okay, so 2 times the tan. Let's go back to our circle or our triangle and see what the tangent is. Tangent is opposite over adjacent. So the tan is 9 over 12, right? So we have the y value over the x, 9 over 12. Let's reduce this right away. 9 over 12 equals, divide them both by 3, 3 over 4. Okay, so we're going to use 3/4 as our tan ratio. 3 over 4. Okay, back to our formula. 2 times 3/4 over 1 minus 3/4 squared. Okay, like I said, lots of fractional things going on with the tangent. So let's divide, right? This is 2 times 3. So let's divide the 2 and the 4 so we can reduce real quick. Okay, 2 divided by 4 is 1/2, so we're going to have a denominator of 2. So our numerator is going to be 3/2. Okay, 2 times 3/4 is 6/4. 2 times 3 is 6. 6/4 reduces to 3/2. Okay, if you didn't catch that. 2 times 3 is 6. 6 divided by 4 reduces to 3/2. And then we have 1 minus 3/4 squared. So we square the 3, we square the 4. That's 9/16. 3/4 squared is 9/16. So now we're running into the issue of having a 1 minus a fraction. So I'm going to change my 1 into a special 1 with a 16 divided by 16. So once again, I am changing my number 1 in order to subtract my fraction. And in order to subtract fractions, your denominators have to be the same. Okay? So 3/2 is on top. 16 minus 9 is 7. 7 over 16 on the bottom. 16 minus 9 is 7. And now I'm running into this situation of dividing by a fraction. Okay, dividing by a fraction. No, we don't divide by fractions here. Instead, we multiply by its reciprocal. So multiply by 16 over 7. Okay, not divide by 7 over 16, but rather multiply by 16 over 7. So let's cancel some things out. 16 divided by 2, that's just 8. So now when I multiply these things together, 3 times 8 is 24, and 1 times 7 is 7. So I get a final answer for my tangent of my double angle as 24 over 7. Okay, so now let's do the reciprocals. Reciprocal of the sine is the cosecant. So the cosecant of my double angle is the reciprocal, which means 25 over 24. right? Reciprocal of the sine, that's my cosecant. My secant is the reciprocal of the cosine. So reciprocal of 7 over 25 is 25 over 7. And the reciprocal of the tan is the cotan, which is the reciprocal of 24/7, which is 7/24. Okay, so there's no formula for the reciprocal ones. They're just the reciprocals of your three original fractions. So cosecant is the flip of the sine, secant is the reverse of the flip, the reciprocal of the cosine, and cotangent is the reciprocal of the tan. Okay, let's see about some other examples. Oh, right, the cosine, it says use the information to draw a triangle, and then find the double angle stuff. So first we want to draw a triangle, and this is telling us where to draw the triangle. It's giving you some specific directions. It's saying the cosine of some angle is -6 over 7, and that angle lives in quadrant 2. Okay? So if we make your origin, quadrant 2 is the top left quadrant. Okay, remember this is called 1, and this is 2, and this is 3, and this is quadrant 4. It goes counterclockwise around your circle from positive, right? So in the first quadrant, everything is positive. In the second quadrant, x is negative and y is positive. In the third quadrant, both your values are negative. And in the fourth quadrant, we have a positive x and a negative y. So when we draw this in the second quadrant, okay, this is what our triangle looks like. And here is your angle theta. Theta is always made with the origin. So there's your origin, there's your right angle. Cosine is the y value over the hypotenuse, which means in the second quadrant, our x value is negative. So there's where your negative goes, -6. And your hypotenuse is always positive. So your hypotenuse is +7, your x value is -6. Okay? But when we do the Pythagorean theorem to figure out what your y value is, we're going to negate that 6 as being negative. It doesn't matter when you put it into the Pythagorean theorem. Okay, so yes, it is a -6 for your triangle, but when you square -6, well, that's the same as if you squared +6. So it really is not going to matter much when we do our calculations. Right, so y squared equals 49 minus 36 is 13. So y is the square root of 13. And notice that's a positive value. Okay, in the second quadrant, y is positive, so it's a positive root 13. So when we do our double angles, it's important to know the sign, right, S-I-G-N, whether it's positive or negative. So the sine of my double angle is 2 times the sine times the cosine. Okay? So the sine here is positive. The sine is positive root 13 over 7. And the cosine is -6 over 7. Okay? The negative is important. Do not forget about the sign, S-I-G-N, of your value. So -6/7 is your cosine. So when I do my fractional multiplication, I do 2 times 13, root 13 times -6. Okay? 2 times root 13 times -6 is -12 root 13. Numbers multiply to numbers, so 2 and 6 I can multiply, but my radical I can't quote-unquote multiply. It just hangs out after your product. So -12 root 13 divided by 7 times 7 is 49. Okay, that's your final answer. We can't reduce 12 and 49 at all. They have no common multipliers. So -12 root 13 over 49. Okay, cosine. We're going to use cosine squared minus sine squared. Okay, or you could have potentially done 2 cosine squared minus 1, right? The key is if you don't like using radicals, then use a formula that doesn't have sine in it, because sine is always going to have a radical. Okay, so I'm going to use it just to practice my radical numbers and to help you with your radical numbers. So once again, cosine was negative 6 over 7, and the sine was root 13 over 7. Root 13 over 7. Okay, so when I square anything, that becomes a positive, right? So negative 6/7 times negative 6/7 is positive 36/49. I square the 6 and I square the 7. Squaring makes things positive, always. Okay, and then minus, right? This is still a minus sign, so we're going to keep the minus sign. And then what happens when I square root 13? That becomes normal 13. And I have to square 7, which is 49. Okay, so 36/49 minus 13/49. 36 minus 13 is 23/49. 23/49. All right, let's look at the tan one. So the tan double angle is 2 times the tangent over 1 minus that tangent squared. So let's see what the tan is. So tan is y over x. The tangent is negative 13, negative root 13 over 6. That's my tangent, the y over the x. Negative root 13 over 6. Okay, so let's get to doing this multiplication. I'm just going to divide. 2 divided by 6 is root 13 over 3. And then negative root 13 squared is positive 13 over 36. Okay, so negative root 13 over 6 squared is normal 13 over 36. Now I'm going to change this into a 36/36 so that I can actually subtract these things. Okay, so this becomes negative root 13 over 3 divided by 23 over 36. So now let's multiply by the reciprocal. So negative root 13 thirds times 36 over 23. So I'm going to simplify by dividing 36 by 3 straight away. 36 divided by 3 is 12. And 23 can't have anything to it. So my final answer is negative 12 root 13 divided by 23. Let's look at our second example. The cotangent of u, some angle u, is negative 6. So we're going to write it as a fraction, negative 6 over 1. So cotan is a ratio of the x to the y, and this is where we're drawing it. So between 3 pi over 2 and 2 pi. Hopefully you know that that's the fourth quadrant. Okay, 2 pi goes directly to the right. 3 pi over 2 goes down, so we're looking at a fourth quadrant triangle. Okay, so this is where our theta is. Theta is here in the fourth quadrant. So if we have a negative 6 as your cotangent, but x has to be positive, that means your y value has to be negative, because cotangent is x over y. So we have a positive 6 for x, and we have a negative 1 for y, because in the fourth quadrant, x is always positive and y is always negative. So we have a positive followed by a negative for every coordinate point in the fourth quadrant. And even when we do the Pythagorean theorem, 36 plus 1 is root 37. So here, our hypotenuse is also going to be positive. Okay, hypotenuse is always positive. So the sine of my double angle, 2 times the sine times the cosine. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So when I multiply these together, and I do 2 times negative 1 times positive 6, that gives me negative 12. And then the denominator, when I do root 37 times root 37, I get 37. Okay, let's look at the cosine double angle. Okay, so we're going to do cosine squared minus sine squared. So cosine is 6 over root 37, and sine is negative 1 over root 37. Okay, when I square my 6, I get 36 over 37 minus negative 1 squared is positive 1 over 37. But the minus sign comes from the minus sign, right? Not from the negative 1 squared. The minus comes from the minus in the middle. So 36 minus 1 is 35 over 37. Okay, notice it's positive because cosine in the fourth quadrant had better be positive. So in order to find the tan, I'm going to do a identity, knowing that tan is the sine over the cosine. Okay, so the sine value was negative 12 over 37, and the cosine value was 35 over 37. And the 37s, when you multiply by the reciprocal, cancel out. So the tangent is negative 12 over 35. Okay, so once again, for all these problems, there's a formula for that. We use Pythagoras to find the missing side, and then you use your fractional skills to find all of these fractions. Thanks. Have a great day.